Hello students, my name is Charu. Welcome to the GATE classes, an initiative by the TEQIP Faculties. So in the last lecture we talked about the threshing technique and what do you understand by segmentation, why there is need of that. So we have discussed some GATE numericals also in the last lecture based on the segmentation part. So next one is page replacement algorithms. Next topic is this page replacement algorithms. So in paging, the page replacement algorithms are needed to decide which pages need to be replaced and whenever the new page arrives. Okay, so the page replacement algorithm decide which page in the memory will be replaced. It is also called as swap out and write to disk. The page replacement algorithm is done when the requested page is not found in the main memory that led to the page fault. So to handle this page fault or to handle the that there is less number of page faults will be there. So we have three different types of algorithms. Optimal page replacement algorithm, least recently used page algorithm. There is most recently used algorithm also, that is just the opposite of LRU. So then is first in first out page replacement algorithm. So whenever the page fault occurs, the operating system has to decide among the newly added pages which page should be replaced, and that page, whatever technique we have to use, we that will be based on this algorithms. So what should be our objective? What should be our objective here? First, that how many frames I can be allocating to the processes, like frame allocation, that correctly I should allocate the frames. How many number of frames will be allocated, that should be the correctly choosing the frame allocation, that is the objective. Second one is page replacement, means page replacement, which page should be replaced. That two objectives should be kept in mind while you are solving these algorithms. Okay, and what is our motive? To reduce the number of page faults. The number of page faults should be reduced by keeping in mind what should be the frame, how many frames should be there, and what should be the page replacement algorithm. Okay, let us understand the first in first out page replacement algorithm. So here we maintain a queue. Okay, the page which is assigned the frame first will be replaced first. So let us consider the string here, the page reference, and they have asked that you take the three frames, page frames we have to take, and find the number of page faults, but we have to use the FIFO technique, that is the first in first out. Let us see what should be the scenario. So let me take the string 3710 710 374 37104. So how many frames I have to take? Three frames I have to take. So I am taking three frames, the memory. Let me insert page number 3. Okay, then 7, then 1. Okay, here also page fault occurs, means this will be there, here also, here also. Okay, because we have to add a page in the frame because it is not initially present, so that is called as page fault. The number of times you have to replace the page in the memory or you have to add new page, that will cause the page fault, or you can say that miss occurs. Okay, so new page arrives 0, that is not present here. Now I have to add this 0 in here by replacing any one of the page. And what should be my criteria? Whatever the page first arrived, that should be out first. So which page is arrived first? 3. So 3 will be out from here. I have replaced this. Then 3 came again. So now 3 is not present here. So I have to add 3 also. Then what next was added? 7. So I will replace 7 by 3. So it will be this thing. So every time you have to replace the pages in the frames, their miss occurs. Okay. Then 3 is there. Okay, 7 came, 7 is not present, so it will be replaced by 1 because initially 1 was added before 3 and 0, so 1 will get replaced by 7. Next 4 will be replaced by 0 because before 3 and 7 0 came, so 4 will be replaced here. Okay, here also miss occurs. Now 3 came, 3 is already present here. 3 is already present here, so here hit occurs because we don't need to replace 3 here, it is already present in the frame. Okay, so next one is 7 is also already in the here, we don't need to change it, here also hit occurs. Then 1 came, so where we should replace 1 will be replaced by 3. So 1 7 4 because 3 came before 7 and 4. 7 and 4 came after 3. So initially, so 3 will be replaced here. Okay. So here also miss occurs. Then 7, 0 will be replaced by 7. So here also I have to replace the page. So miss occur. Next one is 4. 4 is already present here. So it will occur. Right, how many page faults will be there? Wherever you get the miss, there you count the number of page faults: 1 2 3 4 5 6 7 8 9. So total number of page faults will be, I think this is clear to you, that how you can able to find out the number of page faults. Now see, there is some condition. I can increase the size of frame here. Here the frame size is taken as 3. I can increase the frame size to 4 also. See, if I am taking the same string 3 7 1, then 0, then 3 7 4 3 7 1 0, and but the frame size here is 4. Size here is 4 because 4 number of, so I will add 3 here. Then after 3 7 will be added. After 7 1 came, here 0 came, here 3 is already there, so I will not replace here. 7 is also already there, so it will not be replaced. Then 4 came, 4 will be replaced. So which page recently, which page is initially inserted? 3, so it will be replaced by 3. 4 will come in place of 3. Now 3 came. 7 was inserted before 1, 0 and 4. So 7 will be replaced here. So it will be 3, 4, 1 and 0. Then 7 came. 7 will be replaced by 1 because 1 came earlier. Then 3, 4 or 0. So that's why I have replaced here 7. And whenever you have to replace the page, then their page fault occurs. 1 came, 1 will be replaced by 0 because 0 came earlier, then 7, 3 and 4. That's why I have replaced 1 by 0. Okay. Then 0 comes, 0 will be replaced by 4. So 0, 3, 7, 1. Then 4 came, 4 will be replaced by this 3 because 3 came earlier than 7, 1 and 0. Same strategy I have followed in every case. Now see where your hit occurs whenever you no need to change the order. 3710, 3710, it is same. So here hit occurs, it is also same, hit occurs. Okay. In other cases miss occurs because every time you have to insert new page in the memory. So count the number of miss: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many number of page faults are there? 10 number of page faults. Now see, if I have increased the number of frames from 3 to 4, what is happening? Page faults are increasing. So it gave rise to Validy's anomaly. Validy's anomaly. What we have done here, we have increased the number of frames. Number of frames are increased. That led to the increase in number of page faults. That is the Validy's anomaly. There was direct question based on the Validy anomaly in the GATE. So this is very important topic. If you are appearing in theoretical exams also, this is important as well as from GATE point of view. I hope this topic is clear to you, FIFO. Okay. So next one is the optimal page replacement algorithm. The second algorithm for page replacement is your optimal page replacement algorithm. Let me take the string given to you is this one, and they have asked that take the frames, number of frames will be 4 and follow the optimal page replacement algorithm. So what you do here is, here those pages will be replaced which would not be used for longest duration of time in the future. We have to see in the future that the particular pages that are not used for the longest duration of time, we will replace with that page if the new page come. Okay, so let me take the 4 frames. Let me write the string 7, 0, then 1, then 2, then 0, then 5, then 0, 4, followed by 2, 5, 0, 5, 2, then 5, the 2, 5. Here the frame size is 4. And we have to follow the optimal page replacement algorithm. So we will okay, so we'll add 7 here. After 7, 0 will be added, 7 will be 0, 1, then after 1, 2 will be added. Okay. Now, when 0 comes, 0 is already existing, so no need to add new page. So here it will occur. 5. So I have to see here where I have to add 5. Which page should be replaced? So I will see here. I will see this side in future which page is will be not used nearby in the future, right? Which page is not used? 0 is used here, then 2 is used here, then you can replace with the 7. You can replace with the 7 because 0 is used here, 2 is used here. You can either take 1 or you either can replace by 7 because uh, both 7 and 1 are not coming in the nearby future. So you can take either you can replace here with 5 or either you can replace by 1. Okay. So 0. So let me suppose I am replacing with the 7. You can replace with 1 also. Next 0 comes. 0 is already present. So here it occurs. 4. Now I have to add 4. I will see in the near future which pages are there. 2, 5, 0. So it will be replaced by 1. So here I will write 2, 0, 5 and 1 will be replaced by 4 because 1 is not appearing in the near future. So 2 comes, 2 is already there, it occurs. 5 is already there, it occurs. No need to replacement. No need of replacement here also because 0 is already present. 5 is also already present. No need to replace, right? So here also 4, 2. 2 is also already present. No need to change. It occurs. So here also same I will follow because 5 is not replacing any of the previous pages. So it occurs. How many number of page faults here? See. How many number of page faults? 1, 2, 1, 2, 3, 4, 5, 6. 6 number of page faults. Okay. So comparatively less number of page faults are there. Okay. Next one is same string I am taking to solve for LRU and we'll see how many number of page faults will be there. Here also I am taking the frame size as 4 and string this one I am taking and we have to find the number of page faults using LRU test page replacement algorithm. So what is this LRU? Here those pages will be replaced which are least recently used. We have to see the previous pages and whatever the pages are least recently used that we have to replace. And there is condition also most recently used page replacement algorithm. There with whatever pages are mostly recently used, they are going to replace whenever the new page arrives. Okay, let me solve for LIU. String is 7 0 1 2 0 5 0 4 2 5 0 5 2 5. I'm taking the frame size as 4 because it is given in the question. If it is not given in the question, you can take 3 or 4, whatever you want. If it is specified, then you have to check it. If you are doing comparison between the three algorithms, then also you have to take the frame size as same. We are doing the comparison. Only then you are able to compare the number of page faults occurring in the different types of page replacement algorithm. So 7 will arrive here. 7 after 7 0 after 0 1 2 then 0 is already present. Okay, so no need to replacement. Here hit will occurs. Then 5 arrives. We will see here which one is least recently used page. 0 is used, 2 is used, 1. So 7 is least recently used. So I will replace 7 by 5. Okay, 0 is already present. So no need to replace the page. It occurs. 4 will arrive. 0 is used here. 5 is used here. 5 is used here. 2 is used here. So 1 is least recently used. So I will replace by 1. So 4 will come here. Then 2, no need to change because it is already present. It occurs. Then 5, no need to change because it is already present. 0, it is already present here. No need to change. 5 will arrive. No need to change because 5 is already there. 2 is already there. No need to change. Then no need to change for this also because 5 is already present. Okay, so let me count the number of page faults. 1, 2, 3, 4, 5 and 6. Here also number of page faults will be 6 only for the same string, but it depends upon question to question that this number of page faults will vary. Okay, depend upon the question to question. Don't assume that they are same number of page faults whether we'll use LRU or optimal. It's based on this particular reference string that we got the same number of page faults, but it is not the case for every situation. Okay, it depends upon question to question. I hope the algorithms are clear to you. Now we'll practice some GATE questions based on the page replacement algorithms. Okay, so this was GATE 2012 question. The question was that consider the virtual page reference string, that is 1, 2, 3, 4. Let me write here the string 1, 2, 3, 2, 4, 1, 3, 2, 4 and 1. And on a demand page virtual memory system running on a computer system that main memory size of 3 page frames. What is the size of frames here? 3, which is initially empty. Let our LRU least recently used page replacement algorithm FIFO and optimal denote the number of page faults under the corresponding page replacement policy. Now there are 4 different options given to you. You have to compare the different algorithms. So frame size is 3 in all the cases. Let me solve for FIFO. First in first out. What is the size here? 3 frames. So I am taking 3 frames here. So whatever the page is first in, that will be the first out whenever the new page will arrive. That is the condition. 1 is arrived, 1, 2, 3 will arrive. So no need to change here. Okay, so here 1 is added first, so it will be replaced by 4. Then 1 is the new page, it will be replaced by 2. 3 is same, it occurs here, it occurs here also. Then 2 will arrive, it will be replaced here. Then 4 arrives, 1, 2, it occurs, 1 arrive, it is already present, so here also it occurs. Let me count the number of page faults. 1, 2, 3, 4, 5 and 6. How many number of page faults are there? 6 number of page faults. Let me solve for optimal page replacement algorithm. There also I am taking the 3 frames. What is the string here? 1, 2, 3, 2, 4, 1, 3, 2, 4 and 1, right? So 1 will be added, not present there. So 2 will be added, 3 will be added, 2 is already there. So it will occur here. Now optimal में हम क्या देखते हैं? Future में that page should be not nearby. So which page is not nearby? 1 is here, 3 is here, 2 is not there. So 2 is far placed from here. So I will replace by 2 by 4. Okay, replacement is done here. Then 1 is already there, so it will occur. Then 3 is also in present earlier, so it will occur. So 2 will be replaced. 4 is there, 1 is there, so it will be replaced by 3 because 3 is not in the nearby future. Then 4 will be like this only because no change, it occurs. Here 1 is also present there, so no miss or no page fault because no need to change the page in the. So count the page number of page faults. 1, 2, 3, 4 and 5. How many number of page faults are there? 5 number of page faults, less than 3, 4. Let me consider the last algorithm, LIU. 3 frames I am taking. Same string, 1, 2, 3, 2, 4, 1, 3, 2, 4, 1. So LIU means it should not be least recently used. I have to see this side. 1, 1, 2, 1, 2, 3 will be added. Now here it will occur because no need to change the page. Now see here in the nearby 4 because new page came here 4. So 2 is present, 3 is present, 1 is far away. So I will replace here by 1. Here the replacement is done. Then 1 arrive, 4 is there, 2 is there, 3 is far away. Okay. So I will replace 3 by 1. Here replacement is done. Now 3 arrives, 1 is used here, 4 is used here, 2 is far away. Okay. So I will replace 2 by 3. Here replacement is done. And then 2 arrives. 3 is here, 1 is here, 2 is 4 is far away, so I will replace here. So here 3, 1. Now 4 arrives. When 4 arrives, 2 is here, 3 is here, 1 is far away, so it will be replaced by 1. Then 1 arrives at the end, so which 2 is here, 3 is here, 4 is far away, so it will be changed here. Okay. So how many page faults are occurred here? 1, 2, 3, 4, 5, 6, 7, 8, 9. I think 9 number of page faults are there. So they have asked that you have to arrange in the form of number of page faults under the corresponding page replacement policies. So optimal is having largest number of page faults, right? So it is the worst scenario to use this type of page replacement algorithm, then FIFO, then LRU, right? So which option is this? Optimal, FIFO, LRU. This B option is correct one. I hope the explanation is clear to you. Okay. The next one is GATE 2007 question. and this is that a process has been allocated 3 page frames. How many page frames are there? 3. Assume that none of the pages of the process are available in the memory initially. The process makes the following sequence of a page reference string. The reference string is given to you 1, 2, 1, 3, 7, 4, 5, 6, 3, 1. If the optimal page replacement policy is used, how many page faults occur for the above reference string? So what is the string given? 1, 2, 1, 3, 7, 4, 5, 6, 3, 1. Okay. So we have to follow the which policy we have to follow? Optimal page replacement algorithm to follow. How many frames we have to take? 3 number of frames we have to take. Okay. So 1 will arrive, then 2 will arrive, then 1 is already there, so hit will occur. Then whenever you need to add the new page or replace new page, then only page fault occurs. Okay, no need to add the new page here because 1 is already there. So hit occurs 1, 2, 3, then 1. Which one is which one should be replaced? 3 is there. Either you can replace by 2 or either you can replace by, because 2 is not present here, the nearby future. 3 is present here, 1 is present. Yeah. So it will be replaced by 2. 7 will arrive here. Here replacement has done. Then 4 arrives. 4 will be replaced by 7 only because 3 and 1 are there. Okay. Next, which page to uh, replace? 5 came. So 3 in 1 is there. 5 will be replaced. Okay, 6 arrives. 6 will be replaced by 5 because 3 and 1 is there. Then 3 is there. No need to change. Hit occurs. And here also no need to change because 1 is there. So how many page faults are there? 1, 2, 3, 4, 5, 6, 7. The number of page faults will be 7 if you follow the optimal page replacement algorithm, right? And there was question, consider in GATE 2007 only, consider the data given in the above question only. You have to consider the same data, that is the same reference string you have to use. Now you have to follow the LRU page replacement policy. Is a practical approximation to optimal page replacement. For the above reference string, how many more page faults occur with LRU than the optimal page replacement policy? So how many page faults occur if we adopt the optimal page replacement algorithms? We got as 7. Now we have to find out for the LRU, that is the least recently used page replacement algorithm. So we have to find for this one. Okay, so let me consider the reference string. What was it is given as 1, 2, 1, 3, 7, 4, 5, 6, 3 and I have to follow the value. The number of page frames I have to take, because same data I have to take, just difference came in the page replacement policy. So here 1 came, 1, 2 will come. So here no need to replace the page, so hit will occurs. Then 1, 2, 3. 3 will arrive. Now whenever the 7 will come, we have to see here that which page is least recently used. 3 is used, 1 is used. Which one is least recently used? 2. So 7 will be placed here in place of 2. Okay. So next one is 4 will come. So we have to see the near few least recently used pages. 7, 3 is here. We will replace by 1. So 4 will arrive here. 5, 4 is used here. 7 is used here. 3 is least recently used. It will be replaced. 6 will arrive. 5 is used here. 4 is used here. 7 is least recently used. So 6 will arrive here. 7 will be gone. Now 3 arrive here because 3 is here. So 3 comes, 6 is here, 5 is here. It will be replaced by 4. So 3, 6, 5. Here replacement is done. Now 1 came, 1 will be replaced. 3 is here, 6 is here. It will be replaced by, in place of 5 I have to write 1. Because while following the LRU I have to see the least recently used page. So how many number of page faults? 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many number of page faults are there? 9 number of page faults. And if we follow LRU, and we have seen that if we follow the optimal page replacement algorithm, how many number of page faults are there? 7. So how many more number of page faults occur? 2. 9 minus 7 is 2. So option 3 is correct. 2. So 2 more number of page faults occur in the LRU page replacement policy. I hope the page replacement algorithms are clear to you, as we have solved so many examples based on this topic. So if you have any doubt, you can comment below or you can mail also. Thank you.